Hello world, it's Savi. Today I'm gonna present to you my machine learning and computational intelligence assignment about the implementation of MLCI. I took the paper about goal-oriented dialogue system in restaurant and culinary domain by using deep learning. First, the reason why I took this paper because I have been doing research on natural language processing or NLP since my bachelor's degree in computer science. I also took online learning and certification from Coursera about it too. First, the introduction to TensorFlow for artificial intelligence, machine learning, and deep learning. And the second, natural language processing and TensorFlow. First of all, we have to know the differences between artificial intelligence, machine learning, and deep learning. First, artificial intelligence. This is the technique that enables computers to mimic human intelligence by using logic, if-then rules, decision trees, and etc. The second trend is machine learning from 1980s until 2006. The subset of AI that includes abstruse statistical techniques that enable machines to improve at tasks with experience. And the last one, deep learning from 2007 until 2070s, until today, this is the subset of machine learning that composed of algorithms that permit software to train itself to perform tasks like speech and image recognition by exposing multi-layered neural networks to vast amounts of data. So, we got here the graphic of the difference by using deep learning and the machine learning. When to use deep learning or not over others? First, we need to know that deep learning outperform other techniques if the data size is large. Just like this, if we have the same amount of data and we train by using traditional machine learning, it will get the performance, for example, 0.8. And for the large neural network or deep learning, we will achieve the accuracy, for example, 0.99. But with small data size, traditional machine learning algorithms are preferable. For example, this one. We have only small size of data, but we can achieve higher accuracy by using traditional machine learning rather than the deep learning. Because deep learning will reveal the accuracy as best if we have the data size of large. And then the paper itself I got from researcher at Facebook from the ABI dataset. You can use this link to see the paper itself. Nah, I got here the learning end-to-end goal-oriented dialogue. Okay, the paper proposed a test bed to break down the strengths and shortcomings of end-to-end dialogue systems in goal-oriented applications. In restaurant reservation scenario, goal-oriented dialogue requires first, language modeling, just like we should define our user request, and then second, we query the knowledge bases and its properties, just like location, type of cuisine, price range, and etc. And then the last step, we interpret results from queries, options or completing transactions from training set. And then memory networks can be trained to perform non-trivial operations by issuing API calls to KBs and manipulating unlisted training entities. Goal-oriented datasets are designed to train or test dialogue state tracker. Its model conversation is based on partially observable Markov decision process or POMDP. Datasets are based on interactions between users and existing systems, like the STC, SV core, APIS, also BIBA or baby task. So we got here the data set and task type. The amount of KBs datasets are 4,200 of facts. The restaurant datasets are 600 with 5 cuisine types times 5 location types times 3 price ranges times 8 ratings. For the first task, we need to issue the API call. The green one is the user and the blue one is the system or bot. Hi. Hello. What can I help you with today? I'd like to book a table for 6 people in an expensive price range with British food. I'm on it. Where should it be? In London. Okay, let me look into some options for you. And the API will call based on the user request, just like British food, and then London location, and then expensive price range. The second task will update the API calls. Actually, I will prefer for 4. Sure. Is there anything else to update? No. Okay, let me look into some options for you. And API will call some options for its preference. So we have the place and the fancy pop restaurant. The system will display the options. What do you think of this option? The fancy pop. No, I don't like that. Sure, let me find another option for you. What do you think of this option? The place. Let's do it. Great, let me do the reservation. The fourth task is to provide extra information. Can you provide me the address? Here it is, the place address. So the system will represent the address of the place restaurant. You rock! Is there anything else I can help you with? No thanks. You're welcome. And the last task, the fifth task is to conduct the full dialogues. So here it is, the statistical or the distribution of the data sets from every task. If we want to implement deep learning project, we should have extra data sets. So we gather the extra data set by Dialog State Tracking Challenge. The dataset was originally designed for dialog state tracking or DST, hence every dialog turn is labeled with a state. For example, end user intent plus slot to be predicted. The goal is to evaluate end-to-end training, but instead converted the data into the format of our 5 tasks and included it into the dataset as T6, the new task. The second, we gather more information from online concierge service. This is the 4K chats to create extra datasets. All conversations have been anonymized by first removing all user identifiers and then using the Stanford NER taggers or name entity recognition to remove name entities just like locations, timestamps, and etc. And the third, running some manually defined regex to filter out any remaining salient information or phone numbers. The dataset doesn't contain results from API calls, but still records when operator made use of an external service just like Yelp or OpenTable to gather information. The architecture to implement this project, the simulation is based on KB. Facts contain restaurant properties, 10 types of cuisine, 10 choices of location, price range, party size. By using KBs, create user and bot utterances which has 43 patterns and 20 bots scenarios. For the first task, the bot must ask questions for filling the missing fields and eventually generate the correct responding API call. The second task, bot asks to update of user requests or user parameters between 1 until 4 times and must ask users if they are done with their updates and issue the updated API call. And the third task, bot must propose options to users by listing the restaurant names sorted by their corresponding rating from higher to lower until users accept. For each option, users have 25 or 1 per 4 chance of accepting. If they do, the bot must stop displaying options, otherwise propose to the next one. The fourth task, systems will add all the KB's corresponding facts to the dialog. Users then ask for the restaurant's phone number or address or etc. The bot must learn to use the KB facts correctly to answer. And then the last one, combine task 1 until 4 to generate full dialogues. Unlike in task 3, examples are kept if API calls return at least one option instead of 3. So, the model that authors implement for this project is first, rule-based system. This is the heuristic model. The authors initialize a dialog state by using 3 relevant slots for this task, just like cuisine types, location, and price range. And then they analyze the training data and wrote a series of rules that fire for triggers like word matches, positions in the dialog, entity detections, or dialog state to output particular responses. And then API calls and or update a dialog state. Responses are created by combining patterns extracted from the training set with entities detected in the previous turns or stored in the dialog state. Overall, 28 rules are built and 21 patterns are extracted. The second model is the FIDF match. The authors compute a matching score between the input and the response, and the rank responses by score. The score is the TF-IDF weighted quotient similarity between the back-of-words of the input and back-of-words of the candidate response. The third, nearest neighbor. Consider the input to only be the last iterance, and consider the training set as iterance, response pairs that we select from. We use word overlap as the scoring method. Word overlap. When several responses are associated with the same iterance in the training, we sort them by decreasing co-occurrence frequency. Supervised embedding model. Given training data consistent of dialogues, a much more direct and strongly performing training procedure can be used. Predict the next response given by the previous conversation. Just like the typical RNN, recurrent neural network. In this setting, a candidate response Y is scored against the input fxy equals to ax, where a and b are d times v. Dimension times vector word embeddings matrices. For example, input and response are treated as summed backs of embeddings. Consider the case of enforcing A equivalent with B, which sometimes works better and optimizes the choice on the validation set. The embeddings are trained with the margin ranking loss fxy is higher than m plus fxy accent, with m with the size of margin, and we sample n negative candidate responses y accent or y prediction, for example, and train it with SGD. If you want to know more about SGD, you can see this link too from Mem Afia, how to define a stochastic gradient descent. And then we have memory networks model with an additional modification to leverage exact match and types described shortly. Apart from that addition, the main components of the model are first, how it stores the conversation in memory, and then how it reads from the memory to reason about the response, and third, it how how it outputs the response, and then match type features to deal with entities. First, exact match are usually more appropriate to deal with them than approximate matches, and then they frequently appear as OOV, out of vocabulary words. For example, the new name of restaurant. Okay, I'm gonna tell you about stochastic gradient descent in a nutshell. SGD is an iterative method for optimizing an objective function with suitable smoothness properties, for example, differentiable or subdifferentiable. It can be regarded as a stochastic approximation of gradient descent optimization since it replaces the actual gradient calculated from the entire dataset by an estimate thereof calculated from a randomly selected subset of the data, especially in big data applications. This will reduce the computational burden, achieving faster iterations in trade of a slightly lower convergence rate. So, SGD as an important optimization method for machine learning or deep learning. This is deep learning 1 DL. In contrast, performs a parameter update for each training. W for weights, and then N stands for the step size or learning rate or alpha, and then delta QW, it means the sum of QW or the empirical risk, and then QIW equals to the value of the loss function at the ith example. And in the right one, we have the graph of fluctuations in the total objective function as gradient steps with respect to many batches are taken. So we have the result. The authors have introduced an open dataset and task set for evaluating the end-to-end goal-oriented dialogue learning methods by using systematic and control weight. The authors hope this will help foster progress of end-to-end conversational agents because 1. Existing measures of performance either prevent reproducibility or different mechanical turk jobs or do not correlate well with the human judgment. And the second, the breakdown in tasks will help focus research and development to improve the learning methods. And the third, goal-oriented dialogue has clear utility in real applications. The authors also illustrated how to use the testbed by using a variant of end-to-end memory networks, which prove an effective model on this task relative to other baselines, but are still lacking in some key areas. We have here the memory networks that reveal the best score rather than the others. Role-based system for the heuristic model. Okay, I think that's all for my presentation. Thank you so much for your attention, and don't forget to subscribe and like too. Bye.